Okay, in this video we're going to look at another example of hypothesis testing for population variance. So this one is problem number 9 from your textbook in page 459. So let's look at that problem. Page 459, problem number 9. We have an automotive part that must be manufactured to close tolerances, and the production specification calls for a maximum variance in the length of the parts to be 0.0004. Now suppose we take a sample of 30 parts and the sample variance turns out to be 0.0005. And does this mean that we are not keeping to the specification that the variance should be no more than 0.0004? That's what we want to test, and alpha is 0.05. So let's go to Excel. So here population is the length of the automotive part. Sigma is standard deviation of the length of the automotive part. And what we are interested in verifying is, does the sample show that we are exceeding the maximum allowed variance? So that should go in the alternative. So sigma squared is greater than 0.0004, so which means sigma squared. So the problem talks about variance of the part. So the hypothesis must be expressed in terms of variance. So it's less than or equal to 0.0004. So alpha is 0.05 or 5%. Sample data given in the problem is we are taking a sample of 30 and the sample variance turns out to be 0.0005. So chi-squared is, so here is the formula for chi-squared, n minus 1, so n minus 1 times sample variance. So there is already sample variance, so we don't have to square that, divided by the hypothesized value of the population variance, and that's again population variance already. So this is this test statistic, chi-squared 36.25. Degrees of freedom is n minus 1. Now this is a one-tailed test to the right, and therefore our p-value is chi-squared dot dis dot rt, and chi-squared value comma n minus 1. For RT we don't need the comma 1, only for just chi-squared dot dist, which is for the left side p-value, then you need to put comma 1. So this is the p-value. So our conclusion is, since p-value is greater than 5%, do not reject H above. So which means we do not have sufficient sample evidence to conclude that the variance of the length of the automotive parts exceeds the maximum allowed value of 0.0004. If we concluded otherwise, then the probability that we are wrong. That is type 1 error is 16.6%. So let's justify. So here's the second example of hypothesis testing for one population variance, and this is a one-tailed test. The previous example was a two-tailed test.